Have you ever truly looked up at the night sky and asked yourself the fundamental question, are we in this tiny solar system truly the only conscious eyes looking back at the vast expanse of the stars? Consider this absolutely shocking statistic. Astronomers conservatively estimate there are roughly 100 billion planets in our Milky Way galaxy alone. Yet, in the entire recorded history of human observation, we had only confirmed 2 fleeting visitors from deep interstellar space. But that number has just dramatically changed, and the implications of this new finding are both terrifyingly stark and brilliantly profound. We are currently tracking an object 3I Atlas, and the new data strongly suggests it might not be a mere rock at all. Could this be the definitive evidence we have been waiting for? The proof that we are not alone. We continue to keep an extremely close eye on 3I Atlas, an interstellar object roughly the size of the island of Manhattan, which was initially believed to be a natural comet as it moves closer to Earth's orbital vicinity. You absolutely need to check out these new images of the object, which appears to have completely lost its tail. Some serious scientists are now theorizing that this puzzling loss is new evidence that 3I Atlas is not a fragile vaporizing comet, but rather an incredibly durable alien spacecraft or a substantial piece of advanced extraterrestrial technology. The James Webb Space Telescope, JWST, has once again fundamentally reshaped our understanding of the universe when its instruments first discovered this highly unusual interstellar object. Astronomers initially thought it would be similar to other known rogue objects like Oumuamua and 2I Borisov, small chunks of ice or rock ejected from their parent star systems, drifting aimlessly between stars. But as Webb's powerful infrared eyes began to take detailed spectra and images, the data revealed something completely unexpected. 3I Atlas was much, much larger than anyone had initially anticipated. What had been thought to be a modest interstellar traveler turned out to be a celestial body of such enormous size that it immediately defied our basic assumptions about how such massive bodies could exist, let alone survive a violent, catastrophic ejection from a planetary system into the harsh interstellar void. Stick around, because what happens next in this story will absolutely blow your mind with its implications. If you are fascinated by the mystery of Atlas 3I and want to see more amazing, mind-bending cosmic stories like this, hit that like button and let the universe know you're watching. Every single click helps keep the search for the unknown going and the science funded. Comment below and let me know where in the world you're watching this from. I want to see where in the world is witnessing this potential historical discovery with me. The first clear observations became possible as 3I Atlas sharpened through ground-based telescopes, especially with Webb's near-infrared camera, NIRCam. The object had been seen as a dim speck just a few miles across, but deep infrared imaging revealed a massive structure with highly unusual heat reflections and emissions. Analysis of its sheer brightness showed that 3I Atlas was hundreds of miles larger, far larger than any other interstellar object yet reliably recorded. This discovery is scientifically shocking because it is almost impossible for such large, structurally intact bodies to be ejected from their parent star systems using only standard gravitational models. Webb's spectroscopic data suggests a completely different dramatic scenario. 3I Atlas could be the remnant core of a destroyed dwarf planet, carrying with it an unusual, exotic mix of ices, silicates, metals, and complex organic molecules, reflecting a radiation-rich formation environment very different from our own solar systems. Mid-infrared measurements continued to detect ammonia hydrates and complex carbon compounds, strongly suggesting the object had undergone intense internal heating or dramatic tidal deformation at some point in its history. This finding effectively ruled out the possibility of it being a primordial comet and instead bolstered the powerful theory that it was the remnant of a once geologically active icy world that drifted into interstellar space as a failed planet. If large chunks of matter can be violently ejected from stellar systems, our foundational planetary formation models must urgently account for the chaotic extreme interactions in young star clusters, the likely source of 3I Atlas. This object could literally be a frozen memory of a chaotic, ancient stellar nursery. Webb's observations also revealed a thin, brittle crust spewing material through ancient fissures. The slow rate of ejection allowed for measurements of a slow rotation period of several days, consistent with a monolithic, durable structure resilient enough to survive billions of years in the harsh interstellar void. 3I Atlas thus becomes a striking, tangible example of the possibility that the universe contains countless planetary fossils, remnants of destroyed worlds that still carry the precise chemical signatures of distant star systems. If such massive fragments are common, the universe may be experiencing a silent, constant interstellar flow that actively transports complex processed matter to young protoplanetary disks. This could have direct, profound implications for the formation of atmospheres, planetary structures, and even the crucial precursors to life itself. Based on Webb data, simulations now depict 3I Atlas as having a dense rocky core surrounded by thick ice and dust, a configuration strikingly similar to Europa or Enceladus. This opens up the tantalizing possibility that the object once belonged to a celestial body with a subsurface ocean. If true, interstellar space could be filled with the preserved debris of warm, potentially wet worlds that once possessed prebiotic chemical conditions. As 3I Atlas moved closer to the Sun, Webb detected strong sublimation activity, including distinct gas jets rich in polycyclic aromatic hydrocarbons, PAHs, and nitriles, which are important, crucial precursors to amino acids. This was the first time these complex compounds had been definitively detected on an interstellar object, immediately reigniting the panspermia debate, whether the seeds of life could have traveled across the galaxy via durable debris like Atlas. While conditions on 3I Atlas are highly unlikely to sustain life now, the fact that it carries such complex organic molecules makes the theory of biological precursors spreading through space incredibly interesting and plausible. Such clumps of matter that have been wandering for millions of years could effectively act as primordial cargo ships, silently carrying the fundamental building blocks of biology to any star system they happen to pass through. For planetary scientists, the surface structure of 3I Atlas tells an equally fascinating story. Smooth, bright areas interspersed with dark, deeply cratered areas suggest a rich, violent history of collisions and resurfacing that occurred long ago, perhaps when the object was still orbiting its parent star. Some theorize that 3I Atlas was bombarded by a dense asteroid belt or repeatedly hit by smaller moons and asteroids. The dramatic craters and cracks seen in Webb's infrared images depict a world that was devastated by cosmic violence before being violently flung from its star system. Spectroscopic data from JWST also reveal the clear presence of crystalline ice, a material that only forms after long cycles of heating and cooling. This suggests that 3I Atlas was exposed to relatively high temperatures, either from internal heating or from its time orbiting close to its host star. This critical evidence supports the idea that the object was once part of a complex planetary system and may have been in a habitable region where liquid water once existed beneath the surface. The sheer size of 3I Atlas also raises profound questions about how many similar objects are silently drifting between the stars. With their extremely low light reflectivity and modest speeds of movement against the dark background, most of these wanderers are virtually invisible, except when in the immediate vicinity of a star like our Sun. The discovery of 3I Atlas suggests that Interstellar space is not an empty vacuum, but could be a massive repository of ancient debris from the lost worlds of many previous generations of stars. A growing number of researchers are calling objects like 3I Atlas wandering relics, structurally intact fragments of extinct planets that carry the undeniable chemical signatures of distant star systems. Each one is like a perfect sample collection mission from another distant corner of the Milky Way, all without requiring humans to ever leave the solar system. What is particularly remarkable is the immense energy required to eject an object of such significant size from its parent star. Dynamical models indicate that a simple, close interaction with a gas giant is not nearly enough. Instead, a chaotic binary star system could provide a powerful enough gravitational kick to completely tear apart the orbital structure and hurl the object into interstellar space, an event consistent with the unusually high velocity 3I Atlas possesses. Webb's ultra-high resolution also allowed it to detect faint, tenuous dust streaks escaping from the object's surface. Optical analysis revealed that these minute dust grains have isotopic ratios that are distinctly different from those found in our solar system. They reflect origins from a star with a higher metal content and a different oxygen-carbon isotope ratio, effectively making 3I Atlas a chemical messenger from a different, far-off region of the galaxy. When more interstellar objects are analyzed in a similar way, they could help map the chemical composition of the Milky Way in a whole new, unprecedented way. Webb's spectroscopic analysis has produced detailed thermal maps revealing tiny localized hotspots on the surface, localized warm areas that indicate that energy somehow remains inside even at temperatures close to absolute zero. These pockets of heat strongly suggest that slow chemical or geothermal processes can persist for millions of years. This raises the critical question, are interstellar wanderers as completely dead as previously thought? The cultural and philosophical impact of 3I Atlas is equally profound. The image of a massive fragment older than the sun silently passing through our cosmic neighborhood has captured the public imagination. It symbolizes the continuity of matter and time, a powerful reminder that the history of the galaxy is imprinted on every atom in our bodies and in every grain of dust on Earth, a story far older than humanity itself. In capturing its faint light, the Webb telescope essentially captured history itself, history written in frozen rock and carbon drifting silently through space. Now let me draw your careful attention to something even more mysterious that absolutely demands a scientific open mind. We must analyze the tensile strength of this object. If 3I Atlas is truly a natural fragment of a planet, its ability to withstand the immense gravitational shearing forces during its ejection is puzzling and highly improbable. Most natural rocks would simply crumble under such extreme stress. However, if we look at the data on its light reflectivity, albedo, we see it is unusually high for a rock, nearly matching that of polished metal or artificial composites. This brings us directly back to a hypothesis that many conservative scientists are still afraid to touch. Could this object be artificial in nature? Consider the trash of a highly advanced technological civilization. Just as we launch Voyager probes that will outlast our sun, an advanced civilization might have launched huge megastructures billions of years ago. As I, Dr. Michio Kaku, have discussed, if 3I Atlas is a defunct piece of technology, perhaps a solar cell component or a derelict station, its potentially hollow nature would explain the density anomalies we are seeing. A hollow artificial shell would rotate differently than a solid rock, and the tumbling motion we observe perfectly fits the profile of a dysfunctional artificial object. While we actively search for biological signatures, we absolutely must not ignore the technosignatures, the industrial pollution or engineered remnants of others who came before us. This is not mere science fiction, it is the logical, necessary extension of the Copernican principle. We are not special, and our technology is likely not unique in the galaxy. The insights from 3i Atlas fit into a broader scientific goal: deciphering planetary diversity. If exoplanets provide the theoretical models, interstellar visitors like 3i Atlas provide the actual physical evidence. They are traveling specimens from other star systems, giving science direct access to materials that are otherwise completely out of reach. The sheer enormous size of 3i Atlas also hints at the existence of a much larger population of rogue planets. If objects hundreds of miles across can drift through interstellar space, there could be gas planetary cores hidden in the dark. 3i Atlas may be just the first visible sign of a vast rogue population that astronomy is only just beginning to see. The object also became a new benchmark for future missions. Plans began to be drawn up for potential interceptor missions that could study similar objects at close range. A probe traveling at extremely high speeds could one day retrieve samples from an interstellar traveler, providing definitive laboratory analysis of the alien material. Thanks to its enormous size, 3.2 Atlas serves as the perfect test case for designing the orbits and recovery technologies capable of handling such close encounters. While its current orbit is beyond practical reach, it is still serving as a powerful inspiration for a new kind of interstellar exploration mission. Here's the valuable, humbling lesson we must take from 3i Atlas. We often mistakenly think of our solar system as a closed, secure house, but in reality, the windows are wide open. The universe is constantly throwing bricks, letters, and sometimes perhaps messages through those windows. We must remain scientifically humble and intensely curious, for the next object we find might not just be a simple rock, but a greeting. If you enjoyed this deep dive into the profound mysteries of the cosmos, please like and subscribe to our channel. Also, leave a comment below and let us know. Do you think 3i Atlas is just a dead planet, or could it be something technological and artificial? We would love to hear your theories and join the discussion. Thanks for watching, and see you next time as the cosmic drama continues. As we look deeper into the spectral data provided by the NIR-SPEC instrument on the James Webb Space Telescope, we find that the chemical fingerprint of 3i Atlas is even more complex than initially reported. The presence of these complex molecules suggests that the object's parent system may have been located in a region of the galaxy where the metallicity was significantly higher than our own local neighborhood. This implies that the star it orbited was likely much older or formed in a much more dense stellar cluster where supernovae had enriched the surrounding gas clouds with heavy elements. This chemical complexity adds another layer of intrigue to the object's journey. Furthermore, when we analyze the trajectory of 3i Atlas through the interstellar medium, we see that it has likely passed through several different environments, including cold molecular clouds and regions of ionized gas. Each of these environments would have left a subtle mark on its surface, yet the core remains intact. This resilience is what continues to baffle structural engineers and astrophysicists alike. How can a natural body maintain such integrity over such vast distances and timescales? The mathematical probability of a natural planetary fragment maintaining its shape after such a violent birth and subsequent long journey is incredibly low, forcing us to consider all possibilities. If we consider the possibility that 3i Atlas is an ancient probe, its size would suggest it was designed for a long-duration mission, perhaps one involving the transport of massive amounts of data or biological precursors. If it were a seed ship, its current state as a tumbling, seemingly dead object would be consistent with a mission that ended millions, if not billions, of years ago. The heat signatures detected by Webb could then be interpreted not just as geothermal activity, but as the slow decay of radioactive power sources or the lingering thermal inertia of a once active vessel. As the object continues its path out of our solar system, we are left with more questions than answers. The data we have collected will be analyzed for decades to come, serving as a cornerstone for the new field of interstellar archaeology. We are no longer just looking at stars. We are looking at the wreckage and remnants of the systems that surround them. 3i Atlas has changed the game, and the next time we see an interstellar visitor, we will be better prepared to ask the right questions and perhaps even send a craft to meet it halfway. The universe is speaking to us. We just need to learn how to listen.